Hi everyone, this is a tutorial about setting up cameras in IsaacSim, specifically cameras that are mounted on the end of your robot. What we're looking at in front of us here is an ABB Gopher 10 kilogram robot that we're going to refer to as Roger, and Roger's swinging back and forth, and you can see we're visualizing what our cameras inside IsaacSim with the built-in camera visualizations. And he's got a camera on mounted on his flange that is moving around, swinging with him, and rotating a little bit as well. We can toggle IsaacSim cameras on and off with Shift C. So we can see there's our flange here, and we've got our camera mounted as if it was directly on the flange. So looking in our world, we can see how this is set up. We've got our robot mount, our robot, and then down on link 6 off our flange, here's our camera, and we can see the frame for that, and we can look at that, like there we go, and that is how our camera is mounted and how its frame is moving throughout space. So let's go have a look at the code that makes all this happen. So here we are. We are in this code, by the way, is available on our GitHub here at Workr, and then Roger Vision, and it has, you can just clone it and run the main program, and that will work, and you can get this exact demo here. So we'll go through the main program quickly. We've got our normal imports. We load in our robot from our robot library. That's where we get Roger from. We've got a helper for creating our camera here. This is where we set our resolution. This, we set our orientation such that the conventions used in IsaacSim match up with the conventions that our robot flanges are using. We've got another helper function here for setting the camera intrinsics from a K-matrix. And then we make our world. We add the classic ground plane. We set up the single articulation, which will be our robot. We call create camera. We initialize the robot. We reset the world, initialize the robot. We need to set various things just to get the camera set up. These are for depth images as well, but we won't show that in this tutorial. And we also want to get the K-matrix out, and that will allow us to, so that'll show us the original K-matrix, and then we can set a custom K-matrix as well after that, because otherwise it will just be the defaults. Then we just have a while loop, and we go through, this is just for some smooth swinging around of some axes, and we step the world, which makes the motion actually happen. And we can uncomment this section here, and this is going to show you how to get out what the camera is actually seeing in Python and access them as NumPy frames for you to do your computer vision, machine learning, just record what the camera is seeing for other uses. Any of your downstream tasks, this is what you're going to need. But before we do that, let's just quickly see what is the camera seeing in here. So we can see, the floor is spinning around, and we're coming up and doing a bit of a twist. We won't look at that for too long. Go back to perspective here. But that's exactly what we'd expect. So if we come back here and we kill that, now we've uncommented this. We'll run it again, and now we should be getting frames saved into rgb.png, and we should see them updating. VS Code is nice because if you open an image and that image keeps getting overwritten, VS Code will keep showing you that image as it gets overwritten, like all the updates to it. So it's a little bit like video streaming in a way. So we can go here to RGB PNG. Yeah, there we go. So we can see the motions of the image. Super slow. This is not how it's supposed to be used. It's trying to save an image. IsaacSim's trying to run at 60 frames a second here, but it is having to save an image every time. And it's also slowing down our simulation here. So better thing to do is send that image, try and zero copy it over the network or something like that. Send it over your ROS topics, whatever you're working with. So this has been, a tutorial on camera motions inside IsaacSim and how to render them out into Python NumPy arrays, and actually, I think we missed how we actually put it on the end of the robot. So this important part here is the flange prim path, and that is something that we set up here. And this is, we know the prim path of the end of the flange, and so when we're creating the camera, we have to put it on the end of the flange if that's where we want it, for it to be up there and moving. And if we don't specify the flange, it'll just be or another link of the robot that we might want to attach it to, it'll just be floating out in the origin or wherever you set as your translation and orientation is where that will be. So that is the key part, making sure the prim path is set to be a child of the robot's flange. Yes, important part there. All right, thank you for watching.